Hi, in this video we will learn about motion in a circle. Now when we describe motion in a circle, we usually refer to angular quantities than linear quantities. Hence it is very vital to understand some of the concepts on angular quantities. So for example, you need to understand what is angular displacement, you need to understand what is angular velocity. And to understand this concept, let us begin with understanding angle in radians rather than degrees. When we say angle in radian, angle in radian, angle in radian is defined as arc length divided by the radius. So if we take this circle here and we consider this arc length from A to B as S1 and the radius of the circle as R1, then the angle theta here in radians is S1 by R1. Let's take another circle with the same center point but a radius of R2, and we will extend these points here to A dash and B dash, so that we have another arc of length S2 on a circle of radius R2. But note that theta is the same, so angle theta in radians now is equal to S1 by R1, and that's the same as S2 by R2. So the thing here is you can keep increasing the radius so that you get different arc lengths. However, theta in radians is going to remain the same. Now let us say, for the sake of assumption, that we increase the angle theta. If you increase angle theta, then you increase the arc length, and we can keep increasing theta until we increase the arc length to a value which is equal to the radius. So there comes a point when S1 becomes equal to R1. Okay, when that happens, then your angle theta in radian becomes S1 by R1, and since S1 by R1 is equal to 1, you get 1 radian as your angle. So we define 1 radian as the angle subtended at the center of the circle by an arc length equal to radius of the circle. Now let's understand this concept further. Now if you take either the inner circle or the outer circle, let's take any one of these circles, and let's say the circumference of the outer circle is 2 pi R2, right? The entire circle makes an angle of 360 degrees. So just to better understand this, if you start from this point and you move around then and come to the same point, you subtend an angle of 360 degrees, right? So your arc length is 2 pi r2 and your angle subtended in radian is now 360 degrees subtended in radian is equal to arc length, which is 2 pi r2 divided by the radius of the circle, which is r2, so that's 2 pi. So your 360 degrees, which is the angle subtended in radian for the entire circle, is equal to 2 pi. Because now 360 degrees is equal to 2 pi, 1 degree is equal to 2 pi by 360, which is equal to pi by 180 radian. Now if you just reverse this, we can also write this as 1 radian is equal to 180 divided by pi degrees, which is approximately equal to 57.3 degrees. So what that means is, if you take any circle and if you maintain an angle of 57.3 degrees, then the radius here will be equal to the arc length here. So students, I hope the concept of radian is clear, and in the subsequent chapter we will discuss more about angular displacement, angular velocity, and how it relates to the topic motion in a circle.